Assalamualaikum warahmatullahi wabarakatuh and good day. So today I will explain or I will show you solution for exercise 3.6 question number 2. Alright, so if you look the question, a hospital administration, this one, okay? A hospital administration believe that the standard deviation, okay, of the number of people using outpatient surgery per day is greater than 8. So greater than is like this, isn't it? So standard deviation, this one lah, because we are talking about population here. Okay, a random sample of 15 days of recorded number of outpatient surgery is selected. So you can see here is random sample of 15 days. So n equal to 15. Alright, is selected with standard deviation of 11.2. So 11.2 ni is a standard deviation as well. But is it sigma or is it S? It will be S, isn't it? Because this value, you get it from 15 sample. So this is a sample. Alright, sample standard deviation. Now the question, is there enough evidence to support the administration claim? What is the administration claim or administrator claim? The standard deviation greater than 8. Alright. So this is hypothesis testing. Alright. So again, for traditional method, you have 5 steps. Alright. So you have 5 steps. So your first step is write down your hypothesis testing. So this is your first step. Write down your null hypothesis and H1. So just now, our population parameter is standard deviation, isn't it? So usually I prefer you to use variance here like this. Okay. Variance. But if you use sigma, also acceptable lah. But preferable is variance. Okay. So from the previous question, the claim is greater than 8. Okay. So greater than, is it H null or H1? It will be here. Right. Because no equal sign. And then 8. 8 is standard deviation. So here if variance, you have 8 square. Okay. Or sometimes student put the value lah. Alright. 91. So here is the claim. Alright. Because you get it from the question. So this one, if here is greater, here will be less than 8 square. Okay. Again, in step number 1 ni, you must look the area. And for standard deviation, population standard deviation hypothesis, okay, if you remember chapter 2, we use chi-square. So here you also have chi-square, and chi-square figure is skewed to the right. Okay, it's not symmetric. Alright, so here you can see greater than will be at the right side. Okay, here will be your chi-square. So alpha, what is the alpha value here? 1%. So alpha is equal with 0.01. So no need to divide by 2. Okay, because it's a one tail. Okay, and then here you will have nu lah later. The nu is usually n minus 1. So our n just now is 15. So here will be 15 minus 1 is 14. So that's why here will be 0.01. 14. Alright, this is just to show you at early stage. Step number 1, you write down your hypothesis. Make sure you know what is the parameter they're concerned about here. So from the question, they ask you standard deviation, and I advise you to put variance like this. And then it's a greater than, no equal sign. So you put at H1. So here the value, 8 power 2. Alright, so this is the claim that you get from the question. Alright, so now step number 2 is the test statistic. Alright, so test statistic, you can look at your statistical table. We only have one test, which is chi-square test. Right, so chi-square test, okay, the formula is n minus 1, right, s square divided by sigma square naught. Alright, so n is 15. Your s is what just now from the question? 11.2, isn't it? So you will get 11.2, and then your sigma naught is this one. All right. So you substitute the formula. You will substitute the value into the formula. You get 15 minus 1. This one 11.2 square, because this is S only, isn't it? Divide by 8 square. All right. So make sure you clear. Standard deviation, no square. So put here square. Sometimes the question given you variance. So here you just put the value. No need to square. Alright. So when you calculate, so here you will get 27. Okay. Here you will get 27.44. Okay. 4 decimal places. But here is 0, 0. You can do like this lah. Right, so that is step number 2. So step number 3 is critical value. So critical value, it depends on test statistic. If you use chi-square test, so here you will use chi-square table. Alright, chi-square table, okay, here your alpha is 0.01. No need to divide by 2. So here new n minus 1, 15 minus 1, you get 14. Alright. So if you look table, statistical table, page, let me see, it should be page 30, I think, yeah, for 38, alright, page 38. So if you look page 38 too, you have alpha, okay, here is page 38, you have alpha, and then you have mu, isn't it? So alpha find 0.01, and then mu you have from 1. So you find yours is 14. Alright, so 14, and then this is the value. Alright, so if you look the value, it will be 29.1412. Okay. So this is how you find from the table. Okay, page 38. Look alpha, what is the alpha? And then look your new, what is the value? 14. So here is the value, 29.1412. Okay, so that is your step number 3, critical value. Alright, so step number 4, decision. Alright, so decision, I'll show you using figure first. So again, this is not symmetric. Okay, it's a chi-square table or chi-square figure, chi-square distribution. So it will be at the right side here. So here is 29.1412, which is you got it from the statistical table. Now, the comparison is still similar. Reject H null when the chi-square test here, this value is at the dark side. Okay, in this case, greater than 29.1412 lah. So this one, is it at the bright side or at the dark side? Here is at the bright side, isn't it? So since it's at the bright side, so do not reject H null. So here will be do not reject H null. Okay, so how you write it in nicely? So you will say here, do not reject H null. Okay, since, what is it? Here will be chi-square test, which is 27.44 less than chi-square 0.01, 14, which is 29.142. So this is how you write it nicely. Okay, so either one lah. Alright, but preferable write in term of writing. Okay, but if you difficult to do that, I still accept this one lah, because I can see you understand what is it here. Okay, but you must have all this like this. Okay, right. So step number 4, do not reject H null. That's when you take this one. Okay, so what is your conclusion? Step number 5, at alpha 0.01, is there enough evidence to support the claim? No, isn't it? Because you reject H1. So you accept H null, because do not reject H null. So at alpha 0.01, we do not have enough evidence to support the claim, or we have insufficient evidence to support the claim, or we can say that the standard deviation, we can take back this one. Okay, we do not have enough evidence to support the administrator claim. Okay, at alpha 0.01. Okay, so again, for step number 5, if you understand step number 1, inshallah you can write your own words here. Okay, make sure you write down your alpha 0.01. Okay, so I just want to give extra things here. All right, in this case, your area is at the right, isn't it? Okay, sometimes your value here or your notation here less than. Okay, so let's say okay, I'll show you one simple example lah. No, it's okay. I just show you. Let's say here is less than, so here will be greater than equal. All right, so your area will be at the left side, isn't it? All right, so instead of the right side here, your area will be at this left side. So at this left side, it will be 1 minus alpha over 2 mu. So in this case, alpha only lah, because you have one tail, isn't it? So it will be alpha only. So alpha is 0.01. So 1 minus 0.01 is 0.99. Okay, so here will be your new as well. So again, if you look here, you find 0.99 and then you look 14. What is the value here? So in this case, the value will be 4.6604. Okay, if I'm not mistaken here, yes, 4.6604. Okay, so this is just if your question like this. Okay, I want to take note at this part lah. It's not alpha only. You should have 1 minus alpha because this is right skewed figure, right? Like this. Okay, so if right skewed figure, here is start 0 until infinity. Okay, we don't have negative value. Okay, that's why this is suitable for the population standard deviation lah. Alright, okay, try do many questions. Alright, and then look, do you clear or not how to find the value like this? Alright, so I think that's all for today. Thank you, class.